Hi, my name is Glenn Weinrib, and I'm going to talk about how to connect a thermocouple temperature sensor to your Windows computer. A thermocouple measures temperature by outputting a small voltage that varies with temperature in a known manner. One can attach a thermocouple sensor to a Windows computer by first attaching it to an intranet hardware device and then connecting that device to a computer via a USB cable. One can then run intranet software, shown here, click the Setup button, select Thermocouple, select Thermocouple type, select Units, set the minimum and maximum temperature, and then press the Digitize button to plot temperature versus time. After one finishes setting up their sensors, they can save their setup in a file in the Documents Intranet Settings directory using the Save button. One can easily read intranet channels using MATLAB software. To do this, one installs both MATLAB and intranet software and then calls a function to create an intranet object from within MATLAB and load the saved channel settings. After this, one can call a subroutine to read a channel. Intranet is easy to use. This miniature USB-based card cage system accepts a variety of cards which directly attach to sensors, including voltage, current, resistance, thermocouple, thermistor, RTD, strain gauge, load cell, LVDT, pressure, and flow. There's not a specific card for each type of sensor. Instead, all analog input channels have universal inputs that attach to all types of sensors. The method that we use to obtain high accuracy is to place the noisy microprocessor in an external box. The card cage is mostly signal conditioning amplifiers that electrically are very quiet and have several microvolts of internal noise when doing low-level measurements. The maximum sample rate is 166,000 samples per second for all channels. For example, one can digitize 2 channels at 83K each or 3 at 55K each. Several different wiring boxes easily bolt to the cards. The i510 works well with thermocouples. The i511 includes B and C connectors, and the i512 works nicely with strain gauges. 8-pole anti-aliasing filter daughter boards are available for those who desire low-pass filtering. Shown here is a 1 kHz filter. Intranet is available in 4, 8, 12, or 16 slots. So shown here is an 8-slot system. However, in most cases, one can start with the i555, which includes everything one needs to get started. It provides 8 differential voltage inputs, 4 voltage outputs, and 4 digital I/O, along with free strip chart recorder software called Intranet World. This software digitizes, displays, and saves waves to disk. Alternatively, one can program in C or Visual Basic, or work with MATLAB, Excel, Origin, LabVIEW, or Daisy Lab application software. Setting up a sensor is easy. One starts by running the Intranet World software, shown here. Each row corresponds to a different channel, and one can have up to 256 channels. We'll now open the Quick Setup dialog. The wiring diagram to the right shows how to wire your sensor. For example, a thermistor would look like this, and a quarter bridge strain gauge would look like this, and a half bridge strain gauge would look like this. The sensor type is selected in the first menu. We will start with a pressure sensor. In the second menu, we specify the sensor's electrical interface. Some pressure sensors have a voltage output, whereas others, these are voltage output sensors, whereas others output current, and some output a millivolt signal given an excitation voltage input. We will select the -5 volt to +5 volt electrical interface. In the third menu, one selects units. We will select millibar and tell Instranet that full scale is 2000 millibar. We'll also tell the graph to show 2000 millibar full scale. To reduce noise, we'll tell the system to average each point for 0.0166 seconds. 0.166. This corresponds to one 60 Hertz power line cycle, and averaging for this exact duration causes the positive parts of the sign to cancel the negative. For more accuracy, one calibrates using these buttons. We will now press the Update button to lock in our changes. Currently, a half-hertz sine wave generator is attached to this channel, which we see plotted here in real time. At the lower left, we see the sensor updating in real time. We'll now tell the system to digitize 100 points at 10 samples per second per channel. Clicking the Digitize button closes the sensor setup dialog, opens the record page, and starts digitizing. We can press the Stop button at any time to stop, and press the Save button to save waves to disk. One can click the Network tab to return to the list of channels, and click here to enable more channels for digitizing. We'll now go back to the record page, click Start, and digitize more channels. This concludes our tour of Instranet. Thank you for watching.